All three players showed up in the blue team. And if I kill this match, perfect, look at that. In today's video, we're going to be looking at the server side of our matchmaker and lobby system. We've got two videos already that detail the client side setup where we build the UI and process messages that we get from the server. But today we're going to focus on the back end and how we actually save that player data to our match and retrieve it from our database to send back to the Godot client. Let's dive in. So I'm going to be working off some of the existing logic that we had already set up in one of the WebSocket demo videos that I already did. So just keep that in mind. I do have some things already set up and in place, like the API gateway ready, and I've got my Lambda function already wired up to it. And I've also added the configuration for the API gateway permissions there. So just keep that in mind. If you're a little lost, you can just go back and watch those previous videos. If you're new to Lambda or DynamoDB, you might want to strap in. This is going to be a little challenging, but we can get through it. So we're going to start with the main index file here, and we're just going to clean it up a little bit. And what we'll do here is let's just go ahead and stub out all of the files because I have a pretty good idea of what we're going to need here. Okay, so these are the 5 files respectively that will handle everything in this process. I think the first thing we should do is just set up the boilerplate for the DynamoDB client and the WebSocket stuff. And I know we looked at the WebSocket stuff in one of the earlier videos, but I kind of consolidated it and moved it to its own file so it was easier to work with. So let's just take a look. So most of this we've seen from the other examples, but just to recap really quick, we're using the AWS SDK for API gateway management, and we're establishing a API gateway client so that we can post messages back to it. And that post message is again how we send messages back to the client, and that's all that this is doing. So what I'm doing here with this export is I'm exposing a public method for this script so that the other scripts in our project here can call to it. So it just basically encapsulates all that send data and setting up the WebSocket stuff in its own script so we don't have to worry about it. And we can just import this file and then use this export to send messages to the client. The next thing I want to look at is how do we set up our DynamoDB client? So this script is how we access and perform actions on the DynamoDB. We basically just create a DynamoDB client from the AWS SDK, and we just perform some basic configuration, and all this is doing is just exposing this client so that we can have access to it from anywhere else in this project. Okay, so let's close that because we're done there. And the next thing I want to do is add permissions to be able to call to a DynamoDB table. So before we get any further, I actually need to create a DynamoDB table. So when you go over to the DynamoDB console, you can hit create table, and you just want to name it. I'm just going to name it match table. And then for the partition key, we're just going to use PK. And then we're going to actually use a sort key for this one. So we'll say sort key. And you can just leave everything as default for now. And while we're waiting for that table to spin up, let's go ahead and add the permissions on it that we need to actually access and perform actions on it from our Lambda function. So let's go over here and let's click on our role. And let's just go ahead and create an inline policy, and we can search for DynamoDB. So for this demo, the only thing we'll need is query get item, and then under write, we need to be able to update an item and delete an item. And I believe, and put an item. And then we need to also lock it down to a specific table. Let's just add the ARN. So this account, I would just put your region. And then the table name is match table, and then we'll create that. And then we can hit next. We'll just name this. Great, so now we have a policy that'll allow our Lambda function to talk to the DynamoDB table that we just created. If we refresh, we should see it show up there, great. So we have put, delete, get, query, and update item. Okay, so if we head back over to the code side of things, just hit deploy to get rid of that error really quick, and we can expand this out. So we've got our table created, we've got our permissions ready, so we can start to fill out the index file a little bit more just to see how the boilerplate is going to look for this class. Okay, so what we've done here is we've just stubbed out our connection lifecycle and message processing. So basically when a WebSocket client connects, we come in here and it'll just print out WebSocket connected. We don't actually handle anything upon connection. This is really just to give our Lambda function a chance to reject or throttle the connection. So we're not gonna really act on anything like sending messages back or anything. So that's just kind of gonna remain a no op. So the disconnect function, we're going to look at how to handle that towards the end of the video, because I do want to be able to handle when a player leaves the lobby so that we can remove them like we've seen in the demo so far. And then this third action here is message. So any message that comes from the client will pass through this conditional here at the end, and we're going to process all our messages there. And if you don't recall from one of the WebSocket videos, that the way that the WebSocket does work is it's basically going to send you an event type based on whether it's a connect, disconnect, or message. And in this example, what we're doing is just we're handling a connect call, which is just a basically a no op where we just say like, okay, we're just going to print out the WebSocket connected. We're not going to really do anything with it, but it does give our server a chance to throttle or maybe reject the connection. So we don't send any messages back at this point. It's just there to let us know that a client's connected. And then on to the event type of disconnected, we're gonna leverage this to be able to remove players from the lobby if they're still connected and they're still trying to form a match. That way we can remove them from the lobby. And then of course, the event type of message is gonna handle any message that comes in from the client. So everything is gonna be processed through this last conditional right here. Okay, so I wanna import the process message into this, but let's just stub out a little bit first. Okay, so what we've done here so far is stubbed out the main processing message function that all the messages from our client will go through. So now we can import the process message function into our main index file here. So let's just do that. So we've imported the process message script into our index script. And what we're gonna do is go ahead and call process message on any message that comes into this server. Okay, so this little bit of boilerplate here just means that once we get a message, we pass that message as the event body, because all the messages from the client will be attached to the event.body. So what we're doing is just passing in all the parameters into that function. So we have to actually call out the parameter and then we set it. This is basically just like another JSON object so that we can pass these things throughout the different functions. So we'll be seeing that quite a bit in this example. But yeah, really what we're doing is we're passing in the request context because we need to be able to get the domain and stage and be able to send messages back over the socket back to the client. So that's what we're using this for. And then of course, we're gonna pass in the request body, which is just, I just pulled out the body into its own variable here. Okay, so this is basically it. We're gonna also look at how to stub out this disconnect function later, but for now, all the messages that come in will come through this process message function. Okay. So if we look back in our process message, we need to handle all the messages that we saw in the last video. So if you remember, when we make a request from the client, we send that request matches opcode, and then we retrieve the matches from the database and then return that to the client. And there's quite a few opcodes that we did handle. So let's just go ahead and stub those out so we can see what we're going to handle in the future. And since I've already built this once and I've got the demo working, I know which opcodes we're going to use. We saw that in the client side demonstration videos. So I'm just going to go ahead and pre-populate them over here. Okay, so I just stubbed out all the major opcodes that we're going to receive from the client. We have a few more that we're going to send back as well, like player joined and player dropped, but we're not going to handle that. So this is processing messages. So the idea is that this backend server needs to be able to handle messages from that WebSocket that we're connected with to the client. So we're using all those messages that come in here We're going to pass those messages into the process message function, which all will come in here. And as you can see, I've already kind of stubbed out all the opcodes for the major ones we're going to receive, and also stubbed out the method names that we're going to use to build out that functionality. And you can see they're pretty straightforward, like request matches, join matches, etc. So it's going to be pretty straightforward to follow, but it's going to be a little bit of work, so bear with me. And the first thing you'll notice is we do have a little warning down here because we haven't built out the send message to client method yet. So let's just go ahead and do that really quick. Okay, so I've built out the function really quick, and we're passing in our request context, because remember when I said we needed connection ID and domain, stage, etc. That's what we're doing here, because our send message to player function that we developed in the WebSocket client earlier, which is this one right here, has been exposed, but we haven't imported it into that script yet. So let's go ahead and import it so we have access to send those messages back to the client. So the first thing we do in the matchmaker is request matches. And I would like to start into this, but we don't actually have any matches. If you look over under the DynamoDB table and hit explore table items, there's nothing showing up here. We need to be able to create some matches first. So I'm doing something just for this demo purposes. If we skip back over to our client really quick, and I had this little test buttons thing that we had developed, and you can probably just figure this out really quickly. All it is just a quick little button I named create matches. And what we're gonna do with that is we're gonna wire it up into our lobby script. And as you can see down here, it is not correctly configured. So what I did is I created a little function called create mock matches. And I added this create matches opcode, and we're just gonna send that back to our Lambda server that we're working on right now. So let's just go ahead and connect that up really quick. So when we click on that little create matches button, we're gonna make a call to the server with this create matches opcode. And if we look over at our process thing here, we can see this execute process message function. We can see we have an opcode handling here for the create matches opcode. Let's actually build this out, because we actually need to have matches in place in order to be able to do anything at all. And this will be a good starting point. Okay, so I created this function called admin create matches because this isn't really for a player to use. This should be only for administrators or people that are moderators for the game. And it's never probably going to be called from the client. This is just something that we can do for testing purposes, unless of course you guys just want to mess around with your friends and you just want to have this easy way to create or delete matches. You can totally do this. And you can see here, the first thing we have here is this create match call. We don't have any functions called create match right away because we haven't created one. So what we're going to do is create one under our matchmaker script. What that script is going to do is it's going to be the database accessor. So its mainly only purpose is to save or get data out of the database. It's not going to have any functional business logic or anything for the game in it. All of the game and business logic will be in this process message script here. So we're just going to keep it organized that way to make it clean. And so let's go ahead and stub out the matchmaker script really quick. Okay, so first off, we have some imports. This is the DynamoDB client, which we touched on a minute ago. Because this is our database accessor class, that's where we're gonna use all that DynamoDB client calls. And the actual commands that we're gonna run is putting data in, getting data out. This is like getting one item out, and this is getting multiple items out. And of course, delete is deleting it. So these are just SDK, AWS DynamoDB library actions that we use to perform queries and actions on the DynamoDB table itself. So that's all this is going to do, and we'll see the usages of those in a minute. The random UUID is from a crypto library. I actually did a short video on this if you want to check it out, but it's basically what I'm going to be using to generate the unique IDs for our players and matches and etc. So the match table, we're going to pull out of a environment variable, but let's just go ahead and set that up really quick while we're on that. You just come back over to the configuration and you hit environment variables and just add one. And then it's just called match table. That was the name of our table. Okay, great. Okay, so let's maximize that. And so that we have our table there. Okay, so I'm just gonna build out that, where were we at? We were trying to create the create match function. Okay, so we've got our exposed function create match down here, and we're gonna call a private method, which is create match with config. Configuration, I'm just passing the team makeup like 3v3 and then the map name. So we'll just pass that up to this function, and we generate our match UUID because this is the first time we're gonna actually create the match into the database. So we're gonna set our partition key, our sort key, the matches status, like are we matching, are we playing, and then the map name, and then the team makeup, and then of course the target rank. Now, so target rank is really just kind of a dummy variable there, just to illustrate that if you were creating a match and you wanted to have a ranking, you could actually use the target rank and set that to, okay, maybe everybody in the 300 range, and then you can make a little algorithm or a little logic to say like anybody that's plus or minus 10 could be able to join this ranking match. So 310 to 290 or something like that. That's up to you, but I just wanted to add it here for just demo purposes. Partition key and sort key, I don't really want to dive deeply into how DynamoDB works. There's a bit of a steep learning curve, especially to do it correct. But basically what I'm going to do is the matches is just going to have a match ID, and then the sort key for the match is going to be either its info, like what information is in the map. So that's like really what we're going to store here. And then the other types of data that we'll save in our match table, partition key will be the match, but then our sort key will be user. And we'll be able to access this data in a minute, we'll see, in a really nice way so that these queries are really nice. So let me just finish building this out, and then we'll touch on that again in a minute. Okay, so the way we're gonna build this out is the primary keys are gonna look like this. It's gonna be like match, hash sign, or pound, and then it's gonna be some long number, whatever. And then the sort key will look like this. It'll be, we're gonna actually call it, when we create it, it'll be info, hash, match, and then the match ID. So if you're new to DynamoDB and how to set up the single table queries and stuff, this is probably really confusing, but I'm going to link some documentation in there. And if you're interested in me doing a little bit more of a deep dive on how to set up these tables, please let me know and I can do a short video covering that. I'm just going to kind of gloss over it here for now, but just keep in mind that this is like what our partition key and our sort key are going to look like. And together we call that a composite key because we're basically using both of them to query different types of data. So that when we want to access our user data, this will actually be like, instead of info, match, or whatever, we'll just have something like, it'll be like user, hash, and then whatever the user ID is. So just keep that in mind, and we'll revisit that a little bit as we finish out this demo. And I went ahead and created a couple constants for the game status. So when we're matching, that's when the players are allowed to actually join and match into the game. And then of course, when the game starts, we'll change it over to playing. So I just went ahead and took care of those right now. And then while we're in here, let's just go ahead and create the user sort key. And we don't need the hash on info because of the way we're inserting it and the way we're using it. We don't really ever need it. And I'm adding the hash here. I might be able to refactor that, but just for now, I'm just gonna leave the hash symbol off the end of that. Okay, so we've got our create match method here. It's going to create a match in our DynamoDB table with the team makeup and map name we pass in. It's gonna generate a unique match ID, and our sort key will just be the same match ID with a info word prefix in front of it, and then we're going to give it the status of matching, map name, team makeup, and a rank, and then to save it to the DynamoDB. So if this is the first time you've seen DynamoDB, if you're using Node.js, I think I'm using ES6 version, that's why you can see all these mjs.mjs files, the latest version of Node. It allows you to send commands instead of writing queries. I mean, we will get to queries in a second, but this is just a really basic way of saving information to a table. So the put command is basically save. They just call it put. And if you run a put command again over the same primary key with the same sort key, it will actually overwrite it. So just keep that in mind. And this put command, we pass it the table name here, that we got up above from our environment variable. And then of course we pass the item that we want to save. So this is really basic, and then we need to send that command to the DynamoDB client so that it can actually process and save that data. And then for this demonstration, I'm just returning the primary key, or I'm sorry, the partition key. We don't probably need to do that. I'm just gonna leave it in there for now because I don't think we're doing anything with it on the process message side of things. I think we've got our first actual real working DynamoDB query. So let's see how to actually use that. So if we come back over here, we have our create match call, and it's still not showing up correctly, right? So what do we need to do? So we need to come up here and we need to import that Matchmaker script. So let's go ahead and do that really quick. And if you're not familiar with what I'm doing, we're using this new ECMA script or ES modules, a way for packaging the JavaScript code. I'm using the latest version of that, and that's why in these scripts we see this different type of import. I think before you may have been used to seeing require. So to import exported functions from other scripts, all I'm doing is exporting. Actually, I didn't even export it. So, let's export it first. So we'll go ahead and export create match, which is the exposed public function. And then privately, we'll call this create match with config. And since we've exposed it, we should be able to import from the Matchmaker script. This is just exactly how we do that. And so then down here, you'll see that it's no longer complaining. And it should be calling over to there correctly. And we just, and just for this first create match demo, I'm just gonna do one match, which is just the tmake of 3v3 and the map name. So now we also need to get those matches. But first, before we do anything, let's actually see if this works. I'm gonna actually comment that out. And let's see let me just make sure we have this ready. So if we connect to this with a WebSocket, we should be able to connect, and we should be able to come in and send a message. So I think we can actually demo from our other client. Let's update to the WebSocket endpoint, which is over an API gateway. I showed you how to do this in the other video. Just go ahead and grab your API gateway DNS, and we're gonna paste it into the code, and let's try it out. Okay, so now that I've got the API gateway DNS set in place in the project, we can go ahead and run this and call this create matches function. And remember, the create matches is going to call this create mock matches and send a command to our backend, and let's see if we actually get something to work. So all we have to do is hit find matches, and nothing's gonna come back because obviously we haven't done anything to handle that message to find matches. But if we hit this create matches button, we disconnected. Okay, so let me see if it actually worked though. Let's go over here. Because we don't have everything in place, of course it's gonna cause a problem. So it looks like it didn't work at all. Let me make sure. It could be a permissions issue that I may have missed.
A few moments later.
Oh, looks like we have some typos. I can't even find the WebSocket server. Okay, so that's really common when you're typing this out. Yeah, I capitalized server and I didn't capitalize it here. So of course we're not gonna be able to send any messages. You have to be really careful about that. It doesn't really autocomplete. So let's try to run that again. So it's attempting to connect, and it did connect, but it sent back an error right away. Okay, so it looks like I have an error in my process message function. So if we look at line 14, it says JSON isn't a thing. Yeah, obviously that's not a thing. So I forgot to add stringify here. This is like the little things when you're developing in this, it's not going to give you all the warnings right away. So there is a bit of a pain to it. So let's rerun it and just make sure we don't get any exception. Attempting to connect to server, connected server to client, and we got our none response. So congratulations, you made a server that is connecting to your client and is receiving opcodes. And right now we don't have any, we're just sending back that default no op. So let me go ahead and hit create matches and hope for the best. So we did get that no op back again, which is a good sign because we're not handling anything else yet. So let's go over to our DynamoDB table. Looks like we still don't have anything there. So let's check the logs and make sure that we don't have any errors. Okay, so it looks like create matches was received, but our opcode printed out null. So we're doing something wrong in the opcode part right here. Let's see what we're doing. Execute message. Did I set it up wrong? All right, so after a little bit of investigation, I realized that I called stringify and I meant to call parse because we're trying to parse the message that's coming in. And of course, our opcode wouldn't have been registered correctly because if we check the logs, we can see the opcode was undefined here. So that's not gonna do us any good. So we're gonna go ahead and change that to parse. Sorry about that. And we'll go ahead and deploy. And then let's go back over to our client, hit find matches. We got our opcode that's okay. So we did something and message received undefined. Okay, that's okay. So that just means that we didn't send back anything because we're not really doing much right now, but it looks like we successfully created our first match. Okay, great. So here's our DynamoDB table. It's going to look like I was explaining earlier, where you have your match ID and then you have your sort key. And here's your map name, the status, and the rank, and then the team makeup. Great. So we're able to successfully create a match. I would like to get those matches. So the next thing we want to look at is, if you look over at our client, the first thing we do is request to get matches. So when our client requests to get the matches, let's go ahead and build out that process to get them and return them to a client. So I'm getting a little ahead, but like in this admin create function, what we want to do is actually return, in this demo, we actually want to return the matches. So what I would normally do is call this find open matches method, but we haven't stubbed it out yet. So let's just first look at how to build out the request matches, and it'll kind of take care of it for us. So let's just take a look. Okay, so we have our find matches, or our request matches starting to develop, and I want to also build out the find open matches. Now, again, we need to query the database for this. So this is going to be a database query. So we know we're going to have to import that from up here. So we'll go ahead and add that to our Matchmaker. And then I'm going to expose that down here. And of course, we need to make that function exposed here. So let's just move that down. Find open matches. Let's go ahead and name it query matches by status. And the reason why I'm naming it that is instead of find open matches is because behind the scenes, open matches might mean something different for your game. In our case, it just means it's in the matching state. So I wanted to just have this generic get matches by state function, so that if you wanted to query for other match type, you can just leverage that. Okay, so I'm gonna come up here. Okay, so we've got our query matches by status. We pass in our status, and then of course we have our query command. So like we talked about put command earlier, query is the same idea, except we're going to query the Dynamo table on the match table, and we're going to use the index called status partition key index. And we're gonna use a expression attribute name. I know this is probably really confusing if you've never seen how to query DynamoDB before, and I understand that, and I'm gonna touch on this index in a second. So just pretend that it exists and we need to use it. But the idea is that you need a way to query by status. And because we developed our table with a partition key and sort key with the match and info, we don't really have a way to do that easily with Dynamo. But what we can do is create global secondary indexes, where you basically create another field as your partition key. So you could, it basically like remaps the whole table, where that partition key becomes the main querying key. So in this case, we're gonna do status, and then the secondary key, or the sort key I should say, is going to be the match, so that you'll have a list of statuses by matches. And I'll show you what that looks like in a second, but just trust me that that's what we can do. And to actually query by status, because we know we have a status field, we'll set our key condition. So this is like, if you were querying in like a typical relational database, you'd say where like status equals something. Well, that's like the where statement kind of right here. And the status actual value, see, we pass in here, but we set it down here. So this little colon status maps to this colon status, and then the status variable passed in matches there. So that's what this expression attribute values is doing. So we're saying, here's our where function, set the status equal to this. And we always have to use this hash symbol. I know it's like very verbose for DynamoDB, and it does take some time to getting used to, but this expression attribute names is where we set the attribute of what it actually is in the table. So you have to kind of map it. So there's all these like mappings and things, and I'm not gonna get into it in this video, but please, like, I'm gonna link some great resources in the documentation, and we'll just leave it at that for this demonstration. So what this is gonna do is query all the matches that are in the matching status that we just set. So if we search for this again, or was I using it down here? Yep, so everything that is matching, I should probably replace that with this constant that we made. Excellent, okay. So now we have our find matches open, and it should be able to query that table for all the open matches. I'll deploy that. Let's come back over here. So we have request matches. Request matches calls up to this function, and we're gonna use that DynamoDB accessor, database accessor, to get them out. And I just like to print them out for you know, when I'm just trying to build out things. That way we can debug quicker. And before we return the actual matches, we need to kind of sanitize the data a little bit. I mean, you could just return the partition and sort key. I like to obfuscate the data, and I'm not even really doing a great job with it here, but I'm going to actually delete both the partition and sort key off the results coming back to the client. You don't really always want to expose how you're building databases and like what your table structure looks like. And this kind of reveals that a little bit if we return that. But so in general practice, maybe not show those things to your client. And I'm kind of doing that here in this demonstration. But the match primary key that's coming back, it'll say the whole match hash and then the ID. You can even have another ID that comes back with this, like just some like other ID that you generate somewhere else that you don't even query by if you want to be really secure. But for this demo, I got to draw the line somewhere. But for now, I'm just returning match ID. So I'm basically doing a on the fly rework of the data that I'm returning back to the client. And I'm doing that in a few places in this demonstration. So I'm not going to touch on it again, but just so you know, I'm just cleaning up the data a little bit before we send it back to the client. Okay, so now we need to return those to the client. So let's look at that. And you can see here, I'm just taking the list of matches that we got back from our Dynamo table, and I'm sending it under this response attribute. And of course, we're setting our opcode back to request matches because that's what our client expects on the Godot client side. I would probably make a helper method instead of doing this at every single return function, but for this demonstration, that's just what I'm going to use. All right, so this request matches should return to this response message. So we're actually going to overwrite that default message that we've been seeing. So we're going to overwrite it there. And then down here, we're going to call it send message to client with that message that we just created. So that message right here, it's going to be sent here through the send message, and then we pass that back to the client. And that is how the rest of this is going to go, right? It's just going to be, okay, we got an opcode, okay, perform some action. Maybe we got some data back on that action, and we need to return it to the client. So that's basically how the rest of this flow is going to go. It's just a lot of business logic we got to build out and handle those different use cases. Let's actually see if this works. So if we go back to our client and we hit play, we should be able to hit find matches and get matches back. And it looks like we didn't. Looks like we have an issue. And so we have an error in our server. So let's just, I'm sorry. Yeah. So let's go take a look. We have an error type, could not undefined. Let's see. So find open matches. Matchmaker is 54. I know exactly what the problem is. We never created the index. I told you about it and then never created it. Okay, so let's go ahead and create an index really quick. So we'll go view table details, click on index. We're going to create an index, and our partition key is going to be status. And then our sort key is going to be the primary key of the existing table. So the existing status and the existing primary key. So here's our status primary key index that we saw 2 seconds ago. And it's going to refer to that, and we can just leave everything by default. And this is going to take a couple minutes to build out. Okay, so this is going to build out a index, and indexes, like I said, are pretty neat. They kind of repackage your data in the table to very quickly accessible, like subtables almost. Please go check it out and read up about it. It's pretty involved, the level of complexity that these tables can get, but for simple demos, it's not that big of a deal. They also have stuff where you may even want to do where they call like overloading global secondary indexes or indexes, and I recommend looking into that as well. And not all these use cases work for all systems and things you're trying to build, but for this is mostly just for demonstration purposes. It may not be 100% correct because this is a demo and I don't know exactly what the game is going to look like, so I just kind of have to start somewhere, and I might zoom out a little bit and realize, oh, I did this wrong. So bear with me if you notice anything glaring, because this is just for demonstration purposes. So I'm going to check back in a second when this is done creating. All right, so our status partition key index has just finished, and it took a lot longer than I expected. So long so that I actually kicked off the other index I knew we were going to need for this demo. So I'll touch on that in a minute once we get to it. Okay, so with the index set up, if we go back over to our game client, we should be able to query to get the request the matches. And again, we're getting an error. All right, so it looks like the command, I forgot to return any results. So let's just look at how to do that really quick. Okay, so it looks like we weren't returning anything, my mistake. And I know the response is gonna have an items list. That's just the way these queries work. So we send the query command and we get back our list of items, and that query match status should be returned by the find opened, which is called right here. So at this point, we should be able to see something print out. Let's just try our client again really quick, just to make sure we're on the right path. Hit find matches. We're still getting an internal server error. Let's see what's going on. Is not authorized to perform query. So it looks like the actual permissions that we had set up are actually not correct, which does happen from time to time. So if we go back to configuration and we hit general, no, permissions, there we go. And if we just look at this role again really quick, let's look at DynamoDB. So we do have query permission. Maybe this table name isn't correct. It actually does look correct to me. We don't have any permissions to write to the indexes. And because this is an index, let me see if it does set, let's see if that error said index in it. Yeah, okay. So that was an oversight I left off at the beginning. So because we're referencing an index now, you still have to give explicit permissions to indexes when you're working with them with DynamoDB. So let's just go ahead and modify that really quick. I'll just go back to visual. Let's see, right, it'll say right here. See, index, I totally missed that spot earlier, but that's okay. This is good that we're learning as we go. So just hit add ARN. So this account, I like to do my region, any table name, we'll say match, match table, and we'll just say any index on that table, and there's, that should do it. And we'll just go ahead next and save. Any index is allowed. In theory, this should work. So let's go back to our code and go back to our client, I should say, and let's just reload everything. Hit find match. And oh, look, it worked. We got our matches back. So we've got our first end-to-end test working. We've got the request matches going to the server and returning results. So that's the first step in this process. So that's a really good sign. If I was committing this, I would do a commit to Git to make sure we captured our progress so that if we broke something, we knew we could return to a good starting point. So what the next phase was to go to join match, right? So when you run that, it shows the list of matches, and then you click the match to actually join it. So that's going to be a join match request. So that's going to come in right here. So let's just build out that segment really quick. Okay, so to build join match out, we're going to create a method that's local to this class first, and we're going to call it join matches or join match. Okay, so we went ahead and completed and stubbed out this, but you can see we have some missing functions here that we need to fill out. I know it's a pretty hefty looking method, but it's not that bad once we break it down step by step. So the first thing we want to do when we join a match is actually get the match data because we need to be able to figure out, is this match eligible, and like which team we need to stick them in. And, you know, we need to determine like how many players are on each team and that sort of thing. And then we need to take that team data and then add the user to it and then save that to the database. So the first thing we're going to do is we want to get all the match data. So this is like a function that will return everything in the match. So the users, the information, and all that sort of thing. So the get all match data will be another import from the Matchmaker script. So let's go ahead and add that there and switch over to the Matchmaker, and we're going to build out the get all matchmaker. So this is going to be another expose function. Okay, so our query all match data is another query command. We're not using an index on here. We're actually just going to pull off all the match data, including the information and whatever users are playing in it. And the way to do that is we just take our partition key and set it equal to the match ID that's passed in. And you can see we set it up very similar to the other example earlier. And then we go ahead and just return that. So let's make sure we got it all wired. Okay, here's our exposed version. And we'll come back here and great. So we're gonna have a We're going to get all our match data. And the first thing we want to do is get off just the information, right? So that query is going to come off. It's actually going to be this specific row right here that comes out here. And then we want to actually look at that and make sure we're going to determine what are we going to do with that? We're going to look at the team sizes from there, right? No, hold on. No, we're actually going to use that to look up the team makeup. Yeah. So let's first make these constants here. We need to just copy them over in this file. I think we had them over here. Yeah. I think these were the ones we needed. Okay, so we got info and secondary key no hash just means it's going to be user. Okay, so all this is doing is this is just a JavaScript filter on the sort key. So when the data comes back, this is our sort key. I just want to check is the result info because the users are actually going to be added underneath this same partition. So instead of this and then the info, it's going to be this and then a user row. So we'll have some users and then we'll have info. And if we come back over here, that's all we're doing here is we're just saying, hey, does that result start with info? If it does, I want to pull out that off because we want to look at the team makeup, right? So we're pulling that info off there. And we can see right here, we're looking at the team makeup and we're going to determine the match size and we'll build that out in a second. And then we need to get all the existing users, right? So these are the users that have already joined the match. And the way we do that is very similar to the info route where we take the user attribute and we make sure that the sort key begins with user and we don't have any user data. So that's actually going to come back empty for this particular case. So that's all we're doing there is we're just scraping off the users and the info respectively. Now we want to determine the match size. So let's just stick this down at the bottom here. Okay, so all this is going to do, I know for this game, the only makeups I'm going to have is 3v3, 2v2, and 1v1. And we're just going to do a few conditional checks to set the max player per team size. That way we know how to build out our team. So we pass in like 3v3 or 2v2. Otherwise, we just default to 1. So if we look back at where this is used, right up here. So we've got our max players now. Okay, so we've got our info, we've got our users, and then we've got our max player size per team, I should say. So I left myself a note here. So when we build player data, you're always gonna get the player data from your auth system or maybe your user table based off your tokens and your authorization scheme. If you're just like playing around with friends, it's not really a big deal. So don't worry about it too much when you're starting out, but you're never gonna wanna just use whatever the client sent you other than like what's in a token. So this player data is like, I'm gonna set the team, which team they belong to. So it's kind of important if you're in production, but for this demo, it's okay. And the way we're doing it is I'm taking in whatever player ID we passed in. So when you click join match, if you remember in the last video, we send our player ID. So that's all that is. We're just setting the player ID here. And then we're setting the rank based on what they sent, username, and then of course their connection ID. And this is how we link a player to the match. So this is the player data that we're gonna save to DynamoDB. That's it right there. And we need their connection ID because when they come back and we need to send them more data, or we need to, like if someone joins and we need to send messages to the other players in the match, well, we don't really know who's in the other match until we make a query to the DynamoDB table and pull out what players are in that same match. And then because we have their connection ID, we can go ahead and send that connection because it's still active. If it's not active, it won't work, but because it's active, it'll work. Okay, so that's our player data we're gonna save. Then what we're gonna do here is we're gonna query on existing users. Remember, so we got all the users out of the table. We're gonna do a JavaScript filter on team. If it's team 1, these are all the players in team 1, and then we're gonna filter on team 2, and these are all the players in team 2. Pretty easy, pretty straightforward. And then this is just where we figure out which team they belong on. So if team 1 is good and the max player per team hasn't been reached, we just add that player to team 1. So you guys can program this however you want. I'm just doing first come, first serve, gets added to the team. If you want to have some kind of system where you have a mix of different ranked players on different teams and that sort of thing, you can go ahead and do that however you want. I'm just doing it pretty simple. And then of course here we just check for team 2 size and we just add them to team 2. If somehow they're both full, that's a bad thing and they shouldn't get here, and I just kick everybody out and move on. And you guys got to handle that error processing for the game requirements that you may have. So the next thing in this join match thing we want to do is we actually want to perform the action of adding the player to the match. And the add player to match is going to be a reference to the Matchmaker script. So it's going to be another database accessor. So we'll go ahead and stub that out really quick because we know we're going to do it. Let's put it, add player to match, and we're going to just add it right after. This is admin only. Okay, we've got that stubbed out. So we're just going to pass in that player data that we just created with the match ID, and we just need to create this add players to match execute function. Okay. All right, so we've got this function pretty much created. We're going to do another put command. So this is going to save a row to the DynamoDB with the match ID that we're working with. We're going to save that player ID with the appended prefix. So that's that user hash thing up here. And then we're going to set the username, rank, team, and connection ID. So it's pretty straightforward. It's similar to the other put command, and we're going to save it. And then we would just return the match, what will be the match ID in this case, back to the previous request. So let's just go back to where that's getting requested from. What was it again? It was add player to match. Let's just scroll down. Okay. I know this is a bit, but bear with me. So we're just passing in. Yeah, so we don't use the return value here, so it's okay. So this will actually, I mean, you can add validation here. Like I left a little note for myself. If you want to make sure that they're not in there twice somehow, if they snuck in. So this would be a good place to add some validation. This is pretty golden path scenario code. So, if you're going to add this to a production level game, I expect you to build it out a little bit better. So we just add the player to the match. That will save them to the DynamoDB using this function there. So the next thing we want to do is get all the users for the match. And so when a player joins and there's another player already in the match, we need to be able to communicate that message to them and send back a message that they also joined, but we to the other clients, right? But to the player themselves, we also need to get the current list of all the players to send back to them so they know who else is waiting. So that's going to be done. So the person that actually joined, they're going to get back this opcode match players with all the players that are currently in the game. And you can see I kind of build off that request right here. I just like set it to a variable, and then I build out this object with the current users in the match with the actual info. So we're going to return info and the users in the match. So, and that'll get passed to the player that's joining, right? But we still need to notify all the other players that are in the match. And so if there are other players from that existing, remember back here where we first queried who's in the match. So we're going to loop through all those existing clients that are already connected, and we're going to send them a WebSocket message. So that's all this is doing right here. But first, let's just look at how to get users from the match. And again, that's going to be another database accessor. So we need to go over to our Matchmaker script, and let's just build that out. Okay, and then of course we need to actually put in the executable function for that. Passing in match ID. Okay, so now that we've got that built out, let's just take a quick look at this. This is a little bit different. So we're gonna query users for the match. And I guess what this is going to do that's a little different is we want to make sure that we're only getting the users and not like the rest of the match data. And this will all kind of click, I think, later on when I show you the aggregate view of the table data. So everything's pretty much the same. This is still a query command. Here's the mappings because we're going to be using primary key and secondary key and of course rank. But yeah, here's the secondary key usage right here. I couldn't find it for a second. That's why I was wondering. Partition key is going to be our match ID. And of course that's mapped down here to the value that's passed in. And our sort key will match the user's sort key, which is just the user prefix. So user hash So that's just saying, give me all the users in the match. That's just like where match ID equals this and also the users. It's kind of like hard to, if you're coming from a relational background, it's a little different, but it kind of makes sense if you think about it. And so we're just saying, give me the match ID and give me the match with this match ID where this match equals that, where all the sort keys have the user prefix. So if you go back over to the table, you'll have the same ID here. And then for every user in that match, you'll have another row. And instead of info, it'll say user hash and then their ID. And again, we'll look at that in a second. Okay, so that's gonna return all that data. And this, I actually do the sanitizing of the data here really quick, where I just delete the sort key and I add a friendly, client-friendly user ID. And then we just return those items. So let's go back. I don't know if I export this yet. I didn't export it yet. So let's do that, export that. Make sure you do that. You'll definitely stumble on that a couple times, and then we just have to import it over here. And there's probably a cleaner way to do all these imports and exports, but that's just what we're doing now, just to make it very clear for everybody. Okay. So we got our users out of the match based on match ID. That's the way we get it out of DynamoDB. Doing a little bit of cleanup here again on the match info, are just gonna have a client-friendly match ID. We don't need the partition and sort key. And then I build a client-friendly object where our users are gonna be set and the match info. And then again, we're gonna loop through all those existing clients that are connected for this match that, remember, we got back up here, where we got all the users out of the match. That were already there. And we build this little connection info object because we use what the connection info that was sent of the request, that's going to be the wrong client. So we have to build this out separately based on the connection that we pulled from the database. But the domain and stage should be the same. So we can use our request context. That's all I'm saying, is like, we can't use the request context connection ID because that'll go back to the wrong player. So we pass in that data, which is what the send message the client needs. And then we also send them, hey, player joined. And here's the response, which is just, all the match information along with the users. And if we refresh your memory, if we go back to the client really quick, that's going to be down here under this player joined section. And here's that user item, that user's attribute that we get. And if we go back over here, that's what this maps to. And then match info, of course, if we look at the lobby lists, match players. No, I guess I'm not using the match info. So in theory, we could probably get rid of this. I might use it in another use case. So we're just gonna go ahead and leave it for now. But if you don't wanna send the data, or if you don't need to send it, don't send it. Okay, so our players can now join a match, and let's just make sure we have it all wired up. Okay, when join matches hit, we'll hit join match, and then response will just be match players response. So if we go back to the client, match players right here is the step where we move the player into the lobby and we send that response back with the players, and we go ahead and populate that lobby list with all the players. So let's just do a quick demo and see if this works. Find match, should have one match show up. Okay, we've got one match here, and if we click on it, it should look, well, it looks like the request worked, but let's see if it actually added us to the match in the database. Okay, so it didn't. So we do have a bug. So we do have a problem. Of course, typing this all out, I'm sure we'll get a couple. So we got a join match request. So it did come in correctly. And it does give us the match he wanted. So this is the actual request that came in from the client and with the player ID that wanted to join. And of course, we have our join match opcode, and send message to connection was even called, but for some reason we're not actually storing it. So let me just make sure. So if we check, did I not deploy the code? I'm pretty sure I deployed the code. Maybe I didn't deploy the code. Did I deploy the code? Here, let's just rerun it just to be sure. Maybe I didn't deploy it. I didn't deploy the Lambda code. Well, go figure. Okay, so as you can see here in the client, this is exactly what we expected. We joined a match and we're the only people in that match right now. So when we got back that data, so here's that user's data down here, and here's that match info that comes back. So that kind of goes full circle there. And we have our one player who's in the match showed up in the lobby. So now that person's in the lobby, and now let's just go review Dynamo, and maybe this will make a little bit more sense. You can see here that the match ID is exactly the same. So this is like how DynamoDB, there's lots of ways you can approach DynamoDB, but one of the ways is like you have these different partitions, which are like partition keys. So it's like they actually partition out all the data in these chunks, and these like key chunks. And then within each chunk, you can have a bunch of different information. And doing it this way allows you to make a bunch of queries. And like without getting into too much, like with these DynamoDB, when you're building out your table design, you really want to get what your database accessors and actions are going to be done first. And there's like write-ups and like all kinds of stuff on the internet about how to do this. And there's, the experts are few and far between with this stuff, but you kind of need to scrape it together yourself. But if you're interested, let me know and I can hopefully maybe shine some more light on it. But anyways, so all this will kind of be aggregated together. But basically, you can see the connection ID, rank, and team. He was added to team 1, obviously, and username. Let me just show you something really quick. Maybe this will help right here. Hopefully this isn't too early to show you in them. So if you actually aggregate this data into something a little bit easier to look at, there's this like NoSQL modeling tool called NoSQL Workbench. It's a little kludgy to work with sometimes. So here's our match ID, right? So right there's our match ID. So we'll just pick one. So this ends in FF, right? So for FF, we have our info, which is like the map name, what the status is, target rank, and the makeup of the match. But we also have user data, and see how it aggregates it in this nice, this view is like actually how your data is going to come back. And this is like what we call this aggregate view, right? So these are the 2 users in the match, user number 1, user number 2, and you can see their IDs respectively there to each one. So this is really what it's going to look like. Hopefully that kind of paints a better picture than this view. I know you can see how like the columns don't line up or anything, but once you get into this aggregate view, you can see all the info for this match. Here's the info, here's the 2 players with it. And then you can just query this and get everything back, or you can query this key, and then you get this guy's stuff back. Or maybe you want this key and then just this part, and then you get these 2 rows back, or maybe this part and then just info, and then you just get this back. So it's kind of if you're coming from a relational background, it's difficult to wrap your head around it. But I just recommend kind of really just jumping in and just seeing what happens, because the more you do it, the more you get used to it. And I am by no means an expert, but I have a very basic understanding about it. And it's really about use case, right? So once you get in there and you get your use case, then you can dive in and build it out. So the next thing we need to do is let's go back to our join match. So we were able to join match. And then what's going to happen after join match? So check match ready. Okay, we're making progress. So when the player actually joins, this client will make a request back to our Lambda server through this check ready function. We talked about that a lot in the last video, of course. It's an action that tells the server, hey, are we full? Do we have enough players to start the game? So that's all that's going to do. So let's just build that out really quick. Had a typo there, put a Y back on it. So that's going to be another internal function that we'll just add right here. And you can see I'm going to call back to that get all match data again. So we're going to reuse that function, and you'll notice I'm passing it like as an object. That's just the way that these formats work. I'm sure there's probably a different way to do it if you don't like this or you prefer another way. It's the way that I kind of learned when I was looking into this new JavaScript version here. So it's just kind of what I'm rolling with. And so if you're a stickler about that, please go ahead and feel free to correct me or give me some improvements, but this is working. So let's go ahead and finish this one out. Okay, so we've got our check match ready built out, and what we're going to do again is this is like we need the match data out of the database again. So we need to first do another query to get our match data back. So we got that. And then again, we also need to get our match info. So we're going to do that same thing we did earlier and filter out on that info key. Remember, I was just telling you, let me just pull that back up really quick to maybe connect that dot. Okay, so remember I was telling you we're just going to query by info. Right here. So we have this match. Right, so we're going to query, we got the match by match ID, and then we're just going to filter on that data because it's not a lot of data, so we can just pull all the data out. Now you could have done a specific query for info, that's fine, but because I know I'm going to use both info user and the user data, I went ahead and just got everything. So here's that got everything query, and then we're just going to filter on info. So that's what this is doing, and we're going to pull out that info right there. And then of course the same thing, very similar. The user prefix, we're just going to get all the users. So these are going to be, this is going to be an array, and this is just going to be an object. So here's the array of existing users in the match. We're going to pull off each team into their respective variables. So team 1 and team 2. And of course, we're going to determine our match size again. And then what we're going to do is we're going to check, is the game full? Okay, do we have, is team 1 reach the max players, and has team 2 reached the max players? If not, we just basically ignore it and we have a no op down here, okay? And then what we'll do is we need to send the server information back. So this is where if you have a server hosted anywhere, it doesn't have to be AWS, wherever you want to host your Godot server, that's what you need to put here, right? Because this connection information is going to go back to that client. So for now, I'm just testing locally. So I'm going to just use the local host and port that I have running on my machine. So we can just pull these up here. And that should do it. Okay, so because our match is ready to start, because we've got into this, the game is full conditional, we need to update the match, right? So we need to go in our database and we need to update the status to playing, because now we're moving to the playing start because we're full now. So what this is going to do, this set match status playing, is exactly that. And that is another database, Dynamo database successor. So let's just go ahead and add that up there. And then of course we need it down here. Hopefully this order makes sense. I wasn't really sure the best order to knock all this stuff out, but you can always rewatch or come to the Discord and ask some questions and I'll try to help clarify. This is a lot to take in, especially for a beginner, but hopefully some of it makes sense. And this is a starting point. Okay, so we gotta get our match ID passed in. Just copy it from here. Okay, and we got that. We got our match status playing, which is just a playing status. Let's go back down. And we need to build this update match status. So let's just go right here. Nope, that's the admin function. I wanna say that admin function for the bottom. Update match status. Okay, so I stubbed this out and we need to get the match information, right? So just this row right here, we need to get that because we don't need the users. Remember how we were using that other query just a second ago, get all match data? That gave us the users and the info and whatever. We don't need the users here, right? So this is one of those cases where we can just get away with the match information, but we got to build that out really quick. So let's do that. Okay, I'm passing in the match ID here and I'm passing in the status. So we need to also add match ID and status. Okay. All right, so update match status. We just want to update to whatever status we're passing in. So let's grab, this is just a DynamoDB query that we just added, which is here. And now here is a usage of the get command, and same idea, except that you have to pass in this stuff under the key object. That's how these get commands work. So this is like a proper thing you have to do. And then you pass in the information of the command that you want to operate on. So in this case, because we're just getting based on the partition keys match ID and the sort key based on the ID, it's going to be this. It's going to be querying this item and this item right here. So that's what we're doing there. It's kind of like a composite key. So we run that query and we get back that single item, and that is why it's a get. And we got that match back. And then right here, we'll set the status. So now that we have that object, we'll just update the status to whatever was passed in. And then again, here we go. And that put command is going to overwrite that value in the table right here. So it's going to go from matching to playing. And that's all this is doing. And then we just return true because whatever, we got to return something, I guess. Well, you don't have to return anything, but I'm going to go ahead and deploy that this time so we don't forget. And let's see where we're at in this match status, set match playing. Where are we? Okay, so we got our connection info, right? We're going to update the match status to playing. So we just did that. And then at this point, we need to notify all the clients that are connected, right? Everybody's in the lobby. The game is ready to start. The game is full. If it's a 2v2 or 1v1, you'll have 2 and 4 respectively. And you need to send a message letting all those clients know that we're ready to start the game, and you need to give them the connection information, right? So that's all this is doing here. Again, because we're not acting on the connection that was that made this request, we can't just leverage the connection ID of that request context. So we got to build out a custom client info, and then we send that client info to the send message client, and then the actual message that we send is match ready opcode with the connection info data. And if we look back over in the client to kind of put that all together, right here, and maybe I skipped ahead a little bit. Okay, match ready. That's going to give us our IP and port that we're going to print out there, and then we're going to pass that back to start the game and connect to the Godot server. So that's what that loop is. So it's telling everybody, including the guy that made the request, he's just going to send a response back to everybody and let them know to start the game. Okay, so we've got that pretty much wrapped up. Now, the only other thing we need to look at is disconnecting, but because we have this like full circle part, I think working, I think we're ready to actually go ahead and do a test of them joining the game, and then we'll be able to look at a couple things. So let's run 3 instances, one for the server and then one for each client respectively. So it's going to be a 1v1 game. Is this 1v1? No, this is 3v3. So, okay, so I'm going to be lazy right now, and I'm just going to check this guy, and I'm going to delete him. So this is how easy you can edit. Just hit delete. Okay, so it's gone. And right now I just want to edit that 3v3. Let's make it 1v1. Look at that right there. Can edit it in line. Okay, so now what we do is if we want to join that game, it should work because I don't have enough clients to do 2v2 right now, unless I deploy this and put this on EC2. Okay, so I have 1, 2, 3. So let's make this guy a server. So we'll do host mode. Find match should return one match, 1v1 Lambda gray, one Lambda gray. Okay, so we don't have any errors. We're good there. So let's go ahead and join the match. Okay, so now we're in the lobby. And let's click this, and now we're in the lobby, and then the game begins. Look at that. We did our complete end-to-end test. So this is like 95% of the way. You could quit here today, but I wanna do one more thing. So the last thing I'm gonna look at is when a player disconnects, right? So if a player drops, remember on our client side, we got that dropped player message. So we're gonna wanna be able to handle that. We already handle that on the client, right? Because we'll get a drop message, but where does that drop message come from? That player drop come from? So let's build that out, and that should be it for this this whole lengthy tutorial, if you want to call it that. So all the way back in our index function, remember when I was talking about disconnect? So we need to build out this disconnect to handle what happens when a player drops while you're in the lobby. So you've got 3 guys in a lobby and you're waiting for that 4th person, and then one of them leaves. So we don't want to do that. We don't want to have stale data, and we don't. How do you want to handle that? So we need to have a way to remove them from that lobby and make sure that 2 more people can join back in to fill out that game. So let's look at how to do that really quick. Okay, the first thing I want to do is actually add who disconnected. So let's just do event.request context connection ID. Okay, so that way we during debugging you can have a good idea of who can disconnect it, and then we'll wait process disconnect. Okay, so we're just going to stub out this process disconnect method, which again, we're going to add to our process message. I mean, maybe process message as the JavaScript was like not the best name, but I'll let you guys pick a better name. Okay, so now that we've got process disconnect imported, we actually need to build it out. So let's go into our process message file. Let's make sure to add it down here. We're going to export it. And then right here, we can just basically copy paste this, rename it process. And I'm going to say, instead of process message, we'll just say process disconnect. And then let's build out that execution. Let's see where I put the other one. Well, we'll just put it right above. You know what? I want to leave it down here. So let's just put it down here. I'm only sending the request context. I just needed to verify that really quick. So we don't need the request body because we're not doing anything. This is an action that doesn't have a body because this is an action that wasn't sent by the client, right? This is a WebSocket disconnect. So this is a network layer getting a signal that's, hey, this client disconnected. And that's all this callback is doing. It's saying, hey, a client disconnected. And we could just ignore it, but again, there's trouble. So let's just go ahead and take care of that and clean up that lobby. So we're going to process, we're going to send in the request context. So we know who to send so we know like who disconnected and how to handle that. And then we have our execute disconnect. Okay, let's go in here. And let's first isolate who our disconnected client was by their ID. And so we're gonna get the disconnected client, which is this. I think I mentioned it earlier, but so this get user by connection ID is gonna be another database successor, and we need to be able to query on the connection ID. So, because in this context, we don't have a match. We're just getting a network signal that's like, hey, this guy disconnected, good luck, right? And not like, how does our server know what match he belonged to, right? There's no context. However, because we're saving connection IDs, we can actually create an index based on the connection ID and the match. So if we look over in our data table, if we refresh this, we should have some people, right? So we're saving this connection ID, and if you look, it's part of the match. It's the same match ID. These are all the same, right? So if we create an index with connection ID and this match ID, we'll be able to query that. And I kicked that off earlier because of how long the other one took. I wanted to have it ready for us. So that's all I did here. Let me just show you how to recreate it really quick. So it's just connection ID. So I'm just gonna copy that. You just come back in here and just hit connection ID and then PK for the partition key, and you would just hit create index. And then that's, yeah, I wanna leave. And that's how you create this. So now that you have that index and we have our permissions added to allow us this Lambda function to execute on indexes, we're good to go. So let's go ahead and import this getter for the index, and we'll just import it up there. And then over in our database accessor, let's go ahead and export that because we know we're going to need to export that. Okay, and then this one we'll call this get. Okay, so let's build this out. Okay, and then let's make our internal function. Okay, so we've built out the query users by connection ID using that index that I was just talking about. And again, here's the name of the index right there. And all we're doing in this one is we're setting the connection ID, and we'll be able to just pull off and get back a list of people that have this connection ID, or connections that have this connection ID. So this is a pretty basic idea. Because I know that this index should only ever have one person, I hard code it to get me the first result. This may be a little risky. There's some, technical debt that might be involved with this if, use cases get a little differently from this like golden path here, but just know that that's what I'm doing here. And yeah, that should be it. So that's that query command. And I think we've got it all wired up down here. It's passed in, and then we've got it exported there. Just double check everything. Okay, so let's say that worked. Now that we have that disconnected user, we're gonna be able to get the match. So that we go ahead and pull the match out, which is this PK partition key. So now we have the match ID. Now we can reuse that get all match data function that we've been using. So now we have all the match data, and then we get the match info just like before, and match. So if the status is still matching, okay, so this is a little important. So if it's still in the matching stage, right now it's playing, but if it was in matching, that's the only time we care. Because if someone disconnects and this isn't matching, that means they're probably playing the game, and that makes sense. So you're gonna have some disconnects that happen normally when the client, once you get your connection info and you go and connect to the Godot server, this status has already been updated to playing, right? We knew that from when we handled the check match is full case a minute ago. So because it's not matching in that case, it's playing, we just skip it. We don't care, nothing happens. Yeah, we lose a little bit of database cycles by calling and making sure that there isn't a problem, but I think that's a small price to pay to have this really nice functionality of keeping your lobby clean. So the match status matching is just a constant we need to add all the way up here. Let's just put it here. Matching. So if we're in the matching phase, that we need to kick that guy out. So let's go ahead and build out this remove user, and that's going to be another database successor that we need to import. So let's come up here, remove user. Okay, go over to here. We're going to export that, remove user, and let's just go ahead and remove user. Okay, so we got that created, and let's go ahead and create our execution method. All right, so this is our first use of the delete command. So it's pretty straightforward. We got our match again, and of course we got our composite key, which is just the match and user ID. And that again will just match on this partition key and this sort key if this is the user we were deleting, and it would just basically delete that row. So you've been deleted. That's all that's gonna do. And then we just execute the command. So this, hopefully by now you guys are getting the hang of how this works. So I'm just double checking that we've got everything wired up. It's good practice. Let's deploy so we don't forget. And let's backtrack from this. I like this flow because it kind of makes sure that I got everything. Okay, so we use our all match data object that we queried earlier, and I'm basically going to filter on make sure it's actually user data, because this is all the match data. It contains everything. Well, we don't want everything. We just want the users, and we want the users that didn't disconnect. So whoever disconnected, we're gonna ignore the person that disconnected with this. So this is all the remaining users that are still connected. And we need to sanitize the data, because this get all match data is going to give us like all the sort keys and everything out of there. So we don't want to return that. So I'm building a sanitized data list of users to return back to those other clients. So I'm just setting the client friendly user ID and match ID, etc. So we build that in an array, and then we create an object called drop player. You can name this whatever you want. And then I pass in the user ID of the disconnected player. I should have probably named this disconnected ID, disconnected user ID. And that's just the ID of the player disconnected. I don't really think this would be a security concern or anything like that, but the reason why I want to pass it back is in case you want to have a cool effect on maybe targeting in your array or your list of users, like an animation or something. It would be really easy to have that instead of having to parse through everybody. You know exactly who to target in your animation or whatever custom things you want to perform on that user getting kicked out of the match. Whatever, you don't necessarily need this. I don't even think I'm using it. So if you don't want to use it, just don't use it. And then of course that array that we created with the client friendly data, forgot a semicolon. Okay, and then we just loop through all the players, not the sanitized players, but because the sanitized players don't have the connection ID, right? That's another reason why I make this sanitized list that cleaned up data, because we don't need to pass connection ID data back to the client. So we're gonna loop through the data that does have the client, the players that do have the client, and again, make sure that they're not disconnected, because we don't want to send a message to nowhere. And then I overwrite the request context. So the request context is the context of the disconnected player that just disconnected. And it's going to have the correct stage and domain name, but it's not going to have the correct connection ID. So I just overwrite it really quick with the connection that we actually want to send this to. So the remaining players that are still connected, that's all that's doing. And then we send a player dropped opcode and then this message right here back. I'm gonna hit deploy so I don't forget. And just to come full circle with that is this dropped player thing that we were just looking at. And here's that user ID of that player that dropped, if you want to do something special with it, and the users to build back in our lobby. So I think we've got pretty much full circle everything completed here. And I think we're ready to do a disconnect test. Let's see, I wanted to build more matches. Let's see, admin create matches. Let's do this. Let's have a little bit more fun. Let's create, this is just super easy. 1v1, 2v2, and we'll just do another 1v1. So we have, and then we'll name these something else. So let's deploy that. So anytime you hit that create button over here, it'll create new matches. So let's go ahead and hit that button for us. So there's no matches. So we know our code is working, right? Because if you look back in the table, it's playing and because this game is ended, it should say game ended. Okay. Full disclosure, I didn't account for when a game is ended because I don't actually have a game. There's no game over state. It just stays in playing. So for your game, you'll probably change that to complete or ended. But because it's not matching, meaning it's not available for anybody to play in, it's not going to show up here. So we know our code's working. But if we hit this create matches, it throws an exception, which is exactly what we didn't want to do. Okay, so I know exactly what happened here. Okay, so forget that. Go over to our code really quick, and right where we first created this, let me try to remember. I think I'm missing something right here. Let me think for a second. I was staring right at it. Okay, I was staring right at this, and what we want to do here is return those matches. So we're going to add those matches, and then because this is just an admin function, we'll go ahead and return those matches right away, and we'll use that same request matches functionality. So what that means is when we go back over here and we hit find matches, nothing's going to show up again. But if we hit create matches, oh, because it already created them before. I didn't hit it just now. I swear I didn't hit it. It just had already created, but it threw an exception because we didn't actually have this call in there. But if you hit that create thing again, it'll actually refresh this whole list with all the lists. You probably don't believe me. Let me try it. Look at that. So we've got double of everything in here. And again, I didn't make this to expand. It's probably gonna look, yeah, look at that. So here's all the things, how many times that we hit that. I think it's duplicated it because I didn't kill the, that might be a small bug in our client. So what's happening is request matches came in, add matches the UI. I don't think I'm doing a queue free on that button list. Anyways, you guys have a bug to fix, but so I don't want that many matches, but it actually doesn't matter. But we'll go over here really quick, refresh this, and let's see. Just delete like half of these. Okay, so let's finalize this out by testing a disconnect. So let's do find match and find match. And we'll do a 3v3 because I don't want anybody to join right away. Hit find match, and then we'll just hit find match again. Okay, so if we hit 3v3, all 3 players showed up in the blue team. And if I kill this match, perfect. Look at that, no problems. We got our player dropped, message coming back in, and you can see for the 2 clients, we got it twice, which makes sense because we have 2 clients left, and we're left with just the 2 clients that are in that game. And if we want to do a different test, I wonder if I can do a, let's see, do we have a 2v2? Yes, let's do a 2v2. Might be a nicer test. Find match and 2v2 towers. Okay, so if this guy drops out, he's going to be one of the blue players. If I close that, see one of the blue players disappeared, and then we're left with the remaining players. Now, if I kill this connection, what do you think will happen in DynamoDB? So we have 2 users now because that's a completed game, but we haven't played any games from now. So how many users should there be? If you said 2, then you're correct, because when we disconnect, remember, we remove them out of the database. So that's working as expected. They no longer have a match associated with them because I deleted it carelessly when I was doing that earlier. But let's go ahead and make sure that we have a complete end-to-end test before we close out this really long demo. Hopefully you guys are still around. And let's do a host mode, and let's do find match, and we're gonna do storms. Okay, we're in the lobby and we're gonna do storms, and then it joined the game. All right, so we already know we got that. Great, so this is working perfectly. You can see he's still running around, and we've got our synchronization working just like it's been working for a month now, and great. So I think that pretty much wraps up everything I wanted to show in this demo. I know the DynamoDB stuff can be a little overwhelming at times. It's a brand new thing, but I was planning on doing like a little supplemental video on DynamoDB. If you want to see that, let me know in the comments and upvote that like crazy, or give that a like so that I know to focus on that. If you guys hate this, say like, why are you using DynamoDB? Use relational. Well, there's cases for both of them, but I really like Dynamo because it's cheap. It's very, very cheap. I can run this and store data. Their like free tier is massive, and if I got to run a database somewhere, that's going to cost me money, and I don't want to spend money. So I'd rather go the cheap route. There's a little bit of a learning curve, but anyways, let me know if you want to see some more content about that. I do want to just put out like a short video, like a speed run, like basically go to 0 to 60 on how to just create like a really simple DynamoDB table query, that sort of thing. That way you can refer back to it and just see that, because I know this is really lengthy. I recommend starting really small, start really basic. You don't have to conform to any specific DynamoDB, best practices right away. Just get used to it. Just get used to saving data, and you can start simple and then work your way into the more complex table designs. But anyways, if you liked it, make sure you give it a like, and let me know what you think about this. If you like this kind of lengthy demo, make sure you're subscribed. I've got a lot more new stuff coming. Of course, I think we're going to put this Matchmaker lobby stuff to bed for now, and I'm going to focus more on some more typical gameplay, Godot client side things, and involved with how to do, of course, it's going to be multiplayer related. But anyways, make sure you're subscribed, and thanks for watching.